Medication has advanced an incredible amount the last decade and can require very specific coatings in order to accomplish their goal. For example, if you want an oral medication to not dissolve in the acidic gastric environment, but want it to dissolve in the more basic intestines, you would use something called an enteric coating. These coatings can sometimes be expensive or require really obscure materials like hydroxypropyl methylcellulose acetate succinate, or methyl acrylate methacrylic acid copolymers, or corn. Anyway, what if there could be a simpler coating that could resist the many different regions of the human body? That is the purpose of this project. I tested 4 types of coatings. Specimen A is an industrial strength epoxy that has many different uses. Specimen B is just coated with some epoxy that you can get at your local hardware store or even Walmart. However, it can be very difficult to get a consistent coat when using it. Specimen C and D had more of an experimental aspect to them. For both of them, a bonding primer was used in order to put on the epoxy coating that followed, and then a form of appliance epoxy was used as the second layer. For specimen C, after the epoxy was dry, a layer of heavy-duty silicone spray was added as an extra protective layer. Specimen D is a little more interesting, as the coating used is not exactly expected. A mixture of lacquer and air freshener was used. The lacquer was merely a binding agent for the air freshener, but the air freshener itself has hydrophobic aspects to it when it's binded to a solid. Now that the coatings were done, it was time to test them in a simulated gastric environment. The way this was done was by dissolving 3 tablets of HCl with pepsin in 150 milliliters of water. After they were dissolved, the solution's pH was approximately 3, which is around the pH of the gastric environment. The specimens were placed in the solution for 6 hours total. Pictures were taken 30 minutes in, then 1 hour in, and then once every hour. Here are the time lapses for all the specimens. Initially, it seems that all the coatings survived the test with relative ease, with the exception of specimen B. It seems that the coating deteriorated slightly since there was a notable color change in certain areas. However, in order for these to be safe, none of the chemicals would be able to be dissolved, otherwise it could poison the body. So, pictures of the solution were taken, and these were the results. While the solution that specimen A was in didn't have any residue, the other 3 specimens seemed to have some form of contaminant in them. The logical assumption could be that a small part of the coating came off of the specimens, but also it could have been a fly that made a poor decision, much like this spider. It is also possible that the conditions the specimens were left in to dry did not allow certain parts to dry completely, or that there was a spot mist when applying the primer, and thus part of the coating hardened without being binded to the specimen. In conclusion, the only coating that would appear to be safe would be specimen A, since there was 0 deterioration. However, industrial strength epoxy is probably not something you would want to ingest. With that being said, it seems like the hydrophobic layer placed on specimens C and D made them slightly more effective than specimen B, who exhibited the slight color change. Perhaps the future work for these coatings could focus on utilizing a simpler hydrophobic layer with acid-resistant qualities to resist the acidic environment of the body. But none of this would matter if the coatings can't be ensured to be safe to ingest. I would like to thank Dr. Alberto Seguez for allowing me to use the corrosion lab and some materials if they were needed as well, as being there for any questions that arise. I would also like to thank graduate student Enrique Paz for helping me with any possible questions I had as well. Thank you and have a good day.